Welcome back to this day 29 support vector machines review. So we have looked at many different discussions and many different points in SVM topic. So let's revise all of them and see what we have done so far in a high level. So SVM in simple words helps us classify between uh, two classification of data points. For example, let's say we have two classes of dataset. We ask SVM which is the what is the decision boundary that can separate between these two classes with a given dataset. It creates a decision boundary, and it also creates something called it also creates a margin which has a separation between the smallest or the nearest point in both classes. So there are few techniques and few things like C parameter and all of those things that we are going to be looking at in this same sheet. So uh, basically this can be of a simple function. This looks like y is equals to mx plus c. C is b in case of here is an adjustment value. Y can w bar t can be number of features. More number of features can relate to y1 x1 something like that. So consider it that way. So decision function is one of the functions which helps us place any new data either in the positive or the negative side of the decision boundary. So that's part of the decision function. So C parameter, coming to C parameter, so the way that we want our decision boundary to be approached, like for example, it's never always a, in real world datasets, it's never always a straight linear separation between two classes. So there might be a need that we might want to compromise or uh, have strong separation when we are doing training set, and we use C parameter to either define we can have more regularization with the training data set, or we can even have uh, uh, larger or overfitting or clear separation of all the data points in a training set. So we have looked at Moon's data set, and again here we are drawing out linear SVM model with C parameter point 1, point 1 and 10. And similarly, in somewhere around here, if you see, we also have something like RBF kernel, and polynomial kernel also is something that we have here, but we will go there. Okay, so that was about C parameter on a high level. Next is quadratic programming. So all of these things in linear was still doesn't give us a clear separation. So that's where quadratic programming comes in handy. It's an optimization technique which operates under the hood of SPM. So there are two different things in quadratic programming. One is primal and another one is dual. So in case of primal, it uh, decides on how many. Primal is, in simple words, checks on the number of data points and decides on where to put them on the decision boundary line, where to effectively put them. In case of dual programming, it uh, works more on features and less on samples. So that's one understanding, and that's an internal optimization technique under the kernel. So next is we have different types of kernels like RBF Gaussian and polynomial, and we have also looked at linear, which is a very vanilla or a basic one, right? So these are the different formulas for the same. So there are different parameters like gamma and C parameters as well, which we have already talked about. So you can go through all of these graphs and charts with polynomial and RBF kernel. Next is online SVMs and trade-offs. So sometimes there might be a need where there is continuous data input. So we will have to take a clear trade-off when such decision is to be made in building a machine learning model. In case of online approach, we Number of training example grows over time, so a very large dataset, it is practical to have online or incremental linear approach. So that's one case. In case of classical, we have a predefined dataset, and any new dataset we need to retrain the entire model. So that's one thing. So just understand there is online batch learning and all of those things that we looked at our initial um, introductory sections. Not the start of the SPM, but during our initial days, maybe somewhere around the first week or so. SPM regression helps us classify the two data points. That is one thing. It is a linear line, but sometimes there might be points with uh, up or down. So yeah, we are also going to be looking at next set of topics which are corresponding to decision trees, where it is also going to be having parameters like epsilon and such things, where points can be little bit non-linear as well. So yeah, these were few key points, and I have also pasted these set of points to be noted when considering why an SVM should be used. You can go through this. Hope you found this video helpful. Please do like, share and subscribe to my channel. Thank you.